Students, we are in a moving charges and magnetism. We are discussing, okay, already understood moving charges produces magnetism. Okay, it's moving charges and magnetism. We understood Einstein experiment and what is magnetic field, magnetic force. Force experienced by charged particle uniform in uniform magnetic field, that is F is equal to QVB sin theta or Q into V bar cos V bar, and Lorentz force, sum of the electric and magnetic force, means force experienced by charged particle in electric and magnetic field, that we understood Lorentz force. So after that, force acting on current carrying conductor when it is placed in a uniform magnetic field, that is I into L bar cross B bar, F bar is equal to Bell sin theta into n cap, and direction of force acting on current carrying conductor also we understood, and a few numericals also understood on force acting on current carrying conductor. Then today our topic is motion in a combined electric and magnetic field. If the charged particle is moving in a electric and magnetic fields, then what is the advantage? So this is a very important topic in our daily life. Okay, so listen carefully, right? So motion combined electric and magnetic field. Charged particle moving in a electric and magnetic field. Very important topic. Okay, so it is it has very important applications also. Listen carefully. Then first, what is a velocity selector? Velocity selector also, it is also called as what? Velocity filter. Means it is filtering the such velocities. What type of velocities it is filtering? Okay, so this velocity selector is or velocity filter is a device used to select the charged particles of a particular velocity out of a beam of charged particles having different velocities is called a velocity selector. Okay, so this term velocity selector or velocity filter. Okay, what is the expression for velocity selector? Now, so first we are going to understand that. So for understanding that, I taken this is a completely, this setup is called as a velocity selector. So this device consists of two slits, S1 and S2, two slits. Inside this two slits, the plates are there. Okay, these plates, one is positive charged plate, another one is negative charged plate. These plates produce what? Electric field. Okay, the electric field from what? Positive charge to negative charge. Okay, so positive charge to negative charge. Right. So magnetic field here, so perpendicular into the board. Okay, this cross indicates what? Magnetic field perpendicular and into the board. Magnetic field is perpendicular into the board. Okay, electric field is along the negative y-axis. Magnetic field is along the negative z-axis. Okay, electric field is along the which axis? Negative y-axis. Magnetic field along the which axis? Into the board means negative z-axis. Out of the board means positive z-axis. Okay, so magnetic field is along the negative z-axis. Means how this electric field and magnetic field both are perpendicular to each other. One is along the negative y-axis, another one is along the negative z-axis. Okay, so electric field and magnetic field both are what? Perpendicular to each other. This is a magnetic field and so this is a electric field. So how both are perpendicular to each other. So if the electric and magnetic field both are perpendicular to each other, so that is termed as what? Crossed fields. What is meant by crossed fields? If electric field and magnetic field both are perpendicular to each other, that is called as what? Crossed fields. Okay, see, this is electric field is along the negative y-axis. Magnetic field is what? Perpendicular into the board. So this is termed as what? Crossed fields. I hope you understood what is a crossed fields. What is a crossed fields? Okay, if electric field and magnetic field perpendicular to each other, that is called as what? Crossed fields. Okay, now come to our topic. Now S1 slit. So this S1 slit contains what? Beam of charged particles. This S1 slit contains what? Beam of charged particles. This beam of charged particles enter into the S1 slit. Okay, through the S1 slit, this beam of charged particles are going. Okay, these charged particles entering what? Electric field and magnetic field. Okay, when the charged particle is entering into the electric and magnetic field, it experiences some force, no? Okay, what is that force? Lorentz force. That is what the sum of the electric and magnetic force. That force is what sum of the electric and magnetic force. Correct, na? Right. So here, electric field. What is the electric force? In first lesson, you understood what is electric force? E bar into Q. What is the magnetic force? Already we understood the charge particle moving in a magnetic field, it experiences some force. What is that force? Q into V bar cross B bar. Okay, magnetic force is Q into V bar cross B bar, and electric force is what? E into E bar into Q. Here, electric field is along which axis? Along negative y axis. You consider along the negative y axis, unit vector is what? Minus j cap. Means electric force vector quantity, so magnitude is E into Q, and so direction is what? Minus j cap. Now, so Fm bar, magnetic force. What is the magnetic force here? Q into V bar cross B bar. We understood. Okay. So, in the charge particle in electric and magnetic field experience electric force and magnetic force. What is that magnetic force? Q into V bar cross B bar. So, that is Fm is equal to Q into, what is the V bar here? So, V bar is, it is moving along which, the charge particle is moving along which axis? Along the x axis it is moving. The charge particle is moving along which axis? X axis. Then along the x axis unit vector is what? I cap. Then a magnitude is V and direction is what? I cap. V I cap. V bar is V I cap. Cross, what is the magnetic field direction? Magnetic field is into the board. Means along the negative z axis. Along the negative z axis, what is the unit vector? Minus k cap. That means B into minus k cap. Now it is QVB I cap cross minus k cap. What is I cap cross minus k cap? I cap, J cap and k cap. So what do we want? I cap cross k cap. I cap cross k cap in anti-clockwise. I cap cross k cap minus j cap. Okay, I cap cross j cap is what? K cap. J cap cross k cap is what? I cap. But I cap cross k cap in anti-clockwise. Okay, I cap cross k cap is what? Minus j cap. Understand? So minus into minus plus. Already is minus here. I cap cross k cap is minus j cap. Minus into minus plus j cap. Then QVB j cap. So magnetic force along the which axis is acting? Along the positive y axis. J cap is what? Along the positive y axis unit vector. Means magnetic force is acting along which axis? Along the positive y axis. Means magnetic force is along the positive y axis. Electric force along the negative y axis. Okay. Then these values substitute in the electric force and magnetic force, you will get what? F is equal to minus EQ J cap plus QVB J cap. Taken Q and J cap, you can take it common. You will get what here? So F is equal to Q into minus E plus VB J cap. Correct na? F is equal to Q into minus E plus VB J cap. Substitute. Fe is what here? Fe is minus EQ J cap. Okay. Fm is what here? QVB J cap. Here Q J cap taken common. Remaining what? Minus E plus VB. Correct na? This F is equal to Q into minus E plus VB J cap. If adjust the electric and magnetic field, if you adjust the electric and magnetic field, okay na? This is due to these plates, we are applying some electric field now. You can adjust this electric and magnetic field. Understand na? A particular adjusting electric field and magnetic field, net force acting means magnetic force is equal to what? Electric force. Okay, you can adjust the electric and magnetic field. At particular this electric and magnetic fields, electric force is equal to what? Magnetic force. Okay, these magnitudes are equal in opposite direction. Then what happens? The net force acting on charged particle is 0. When net force acting on charged particle is 0, how the charged particle can be moved? The charged particle can be moved in a straight line. Correct now? Why? Because on the charged particle there is no force experiences. There is no force experience something, but the charged particle can be moved in the straight line path. Okay, when it is happen, so net force acting on the charged particle is 0. Okay, then minus E plus VB is equal to 0. Then E is equal to VB. Okay, from this we can write V is equal to E by B. Okay, this is a velocity selector. If you send a different okay charged beam of particles here, okay, few charged particles goes in a straight line. Okay, so when it goes in a straight line, the charged particle does not experience in any force. Okay, when does happen? So V is equal to E by B. Remaining particles maybe go like this or go like this, but few particles go in a straight line. Why the few particles go in a straight line? So how much magnetic force acting upward, that much electric force is acting downward. That's why the net force acting on charged particle in this what is the direction? That is 0. Correct? The net force acting on the particle is 0 means, so minus E plus Vb is equal to 0, then E is equal to Vb. From this, V is equal to, V bring this side, you will get V is equal to what? E by V. E is a magnitude of electric field, B is a magnitude of magnetic field. This is called as velocity selector. Few charged particle velocities here. Okay, that charged particle selected velocity, okay, in this direction. Okay, in this direction the charged particle select velocity. How much it is? E by V. Okay, why? Because in this path what happens? There is no net force acting on the charged particle. Okay, or downward deviating, upward deviating, okay, downward deviating or upward deviating, what happens? There is some force will be experiences. Understand now? Okay, if electric force is more than magnetic force, the charged particle deflect downward. If the magnetic force is more than electric force, the charged particle can be deflect upward. But here straight line is going nothing but the electric force, much electric force is there, that much magnetic force acting. The net force acting on the charged particle 0 means in this straight line the charged particles, few charged particles can be in the beam of charged particle, few charged particles can be going along the straight line. Okay, so that is which velocity? How much velocity it has? E by V. Okay, at S2 that charged particles, okay, now which charged particle? So V is equal to E by V. Then at this S2, so what is the speed of the charged particle? Okay, E by V. E is electric field, B is magnetic field. We know that electric field, how much electric field we are applying, how much magnetic field we are applying, we know that. So those values substitute in this formula, will get a velocity charged particle. Okay, you can apply one more magnetic field here. Okay, that charged particle is going with the speed what? E by V. E by V. Which E? This E and this V. Another magnetic field here. Okay, the particle going nothing but, so it is what happened? The charged particle is moving perpendicular to the magnetic field. Okay, or it is some angle with magnetic field going nothing but, it can be select the helical path or circular path. Already we understood that one. Okay, so with the help of this experiment, we are understanding what? So speed of the particle. We don't know how to calculate speed of the particle. By help of this, okay, what is it? Setup. Right? By using this device, we are calculating what is speed of the particle, that is E by B. By using E and B, we are calculating speed. Okay, that's the speed information. Okay, we are using in some applications. Right? I hope you understand. Motion in combined electric and magnetic fields. Velocity selector. What is a velocity selector? A device used to select the charged particles of a particular velocity out of a beam of charged particles having different velocities is called what? Velocity selector. Okay, what is a velocity selector? The charged particle moving along the straight line. Okay, the charged particle does not experience any force. Okay, the charged particle speed how much here? E by B. Correct na?